Hello learners, welcome back to my channel Shraddha's Physics. So here we are continuing our lecture with the operational amplifier. So first of all we will see the output offset voltage, then input offset voltage and input offset current as well. And that after we will discuss on the slew rate of the op amp. Now let us first start the output offset voltage. So basically we can draw the block diagram of the op amp. So this is the op amp and having inverting as well as the non-inverting terminal. This one is the negative terminal is the inverting and the positive one is the non-inverting terminal. These are the input and here having the output terminal. Suppose this is VO and here in case of the output offset voltage, if I will sort these two, that is if I will give the common voltage to the input, that is your inverting as well as non-inverting terminal, and that after it has been suppose grounded, then we will get the output offset voltage. So basically we can write it is the voltage available it is the voltage available at the output terminal of an op amp, output terminal of an op amp, that is operational amplifier, when no input signal or when no input signal voltage is applied. When no input signal voltage is applied. Okay. So now basically you can see that there are two types of the terminal, input terminal. One is your inverting as well as non-inverting. So we have to just sort these two terminal and then you have to take the ground connection to this input. So here we can say that there will be no signal across the input terminal, so that you will get no output voltage. So this type of voltage is basically known as the output offset voltage. So in case of the ideal op amp, so for an ideal op amp, that is when you will give no signal across the input. So for an ideal op amp you will get the output voltage to be 0, and that is your output offset voltage. So O means output and O means offset. Okay, so this output offset voltage equal to 0 for an ideal op amp. Okay, but in case of the practical op amp, but for a practical op amp, when you will consider a practical op amp, so in that case this output offset voltage VOO, output offset, is not equal to 0. So this is called the output offset voltage. When no input signal is given, then we will get the output voltage equal to 0, that is the output offset voltage. And in case of the ideal op amp, this is equal to 0, but in case of the practical op amp, this is not equal to 0. Then we will see what is input offset voltage. Suppose this is our operational amplifier having the output one, and in the inverting one, suppose here I am giving some voltage supply, this is your inverting one, and here I am giving some signal here, and also this is your non-inverting one, here I am giving some signal, that is here I am applying some voltage at this point, and finally these are being grounded and it is connected like this. Okay, now suppose this point is known as, this is your, let me write, this is V minus voltage and this is your V plus voltage, and here the current is suppose I1 and this is suppose I2. Okay, or you can write this as, this is your V1 current and this is your V2 current, and this is suppose current I1 and I2. Okay, now this is your output voltage, this is VO. So here what is input offset voltage? It is the voltage, it is the voltage applied, is a voltage applied between the two input terminals means inverting and non-inverting, between the two input terminals to balance the output offset voltage to balance the output offset voltage of the op amp. So output offset voltage means for the ideal op amp that voltage should be 0. So to balance that we have to apply some voltage across this inverting terminal as well as this non-inverting terminal. Okay, so that voltage is called as the input offset voltage. Okay, so it is the voltage applied between the two input terminals to balance the output of offset voltage of an op amp. So simply we can say this input offset voltage. So the input offset voltage, this is the difference between these two, inverting and non-inverting. So we can write the input offset voltage. The input offset voltage, that is just like the differential voltage, we can say. This input offset voltage, that is V equal to V1. So here for the non-inverting, let me write this is your V2 minus V1. Okay, this is the input offset voltage. Now for the ideal op amp, for an ideal op amp, we can write the input VIO, input offset voltage. Okay, this is VIO. So input offset voltage is equal to 0. But for the practical op amp, this is not equal to 0. So for practical op amp, I can write V input offset IO, that is not equal to 0. So to balance that output offset voltage, the signal that we are applying across the inverting and the non-inverting terminal, that is called the input offset voltage. And this is basically the difference between the inverting terminal and the non-inverting terminal, that is V2 minus V1. And that is for the ideal op amp, that input offset voltage should be equal to 0. But for the practical op amp, you will not get exactly the 0 result. Now let us see what is input offset current. Now we can see across the inverting terminal the current is I1, and across the non-inverting the current is flowing through the op amp is your I2. So now this input offset current, we can simply write the input, so the current I, input offset IO. So that is equal to I, that is for the non-inverting, this is I2 minus I1. So simply I can write here, this is I2 minus I1. This is the difference in the current, we can say. So that this is the case when the VO equal to 0, that is the output voltage equal to 0. So for an ideal op amp, so this current equal to 0. For an ideal op amp, the current for the input offset, okay, this input offset current equal to 0. But for the practical op amp, this is not equal to 0. For the practical op amp, operational amplifier, the input offset current, that is not equal to 0. Okay. So here if I summarize all these things, that is the output offset voltage is when you will give no signal across the input terminal, you will basically get the 0 result across the output. But here in case of the input offset voltage, if I will consider this output voltage to be 0, so to get the output offset voltage to be 0, you have to give some voltage across this inverting and non-inverting terminal in such a way that these two input terminal, they will balance that output offset voltage. Okay. So similarly here in this case, for the ideal op amp, the input offset voltage is 0, but input offset voltage is not 0 for the practical op amp. And also we have calculated input offset current. Now we will discuss on the slew rate. So slew rate is the maximum rate of change. It is the maximum rate of change of output voltage per unit time. Output voltage per unit time. Okay. So basically if I will write, this is your per unit time. Okay. So now simply if I write this slew rate as SR, slew rate, S for slew, R for rate. So this slew rate can be defined as the rate of change of, that is d by dt of the output voltage, that is VO maximum. Okay, that is, this is the maximum rate of change of the output voltage per unit time, we can say. So basically what it will define, that is it indicates, that is this slew rate, it indicates how rapidly the output voltage, of an op amp can change with the change in the change of input frequency, that is, if you will change the input frequency, then how the output voltage will vary, it will define that slew rate. Okay, now also for high frequency, if I write for high frequency, that is for high frequency application of the op amp, for high frequency applications of the op amp must have high slew rate. Okay, so if I write nu max, that is maximum frequency, if I will give at the input, then you will get slew rate divided by 2 pi Vp. So this Vp is nothing but the peak output voltage. This is the peak output voltage. So these are the small definitions of the slew rate. Okay, so now you can see, so the slew rate, it is the maximum rate of change of the output voltage for unit time, and basically it indicates, if you will change the input frequency, then you will see how rapidly the output voltage of an op amp will change. That is, when the frequency is higher, you will get higher slew rate. So this is all for today. Thank you all.